All right, yellow question. Hannah, what is a type of gas that you're familiar with that we compress? Pardon? Helium. Okay, we compress helium, and you can use it to expand balloons, right? Okay. So when we compress helium, what do we put it in? Another yellow question. What do we put it like in a? So say you go to the dollar store to get helium. What is it in? A tank fan. Okay, good. All right. So that was another yellow question. Good. Okay. So, Evan, green question. Okay. Why does helium? Tell me about. I should have made my question earlier. Explain why I can put a lot of helium into that container.
Because gases are compressible.
Tell me about the volume and pressure of that gas in that container.
Pressure increases the volume, increases the space.
Okay, can you use that information and explain it with the container specifically?
Container lets it hold more because it's more compressed. Pressure's higher and the volume is higher.
Okay, so we are compressing more molecules in, so we have a higher density of molecules in there. So we actually are going to have a higher, as pressure increases, the volume will decrease. So like if I'm taking a bunch of helium, so say I have the same amount of helium. So say I have here in my arms, okay, just pretend 100 helium molecules, okay? If I try and compress them in tighter, is the volume of my arms increasing or decreasing? It's decreasing, right? Okay. So the volume of the container is decreasing. What is happening to the pressure that's being exerted on the container, my arms? The pressure is increasing, okay? So this is a little it's different because when yesterday we talked about the pop can thing, we talked about that the volume of space that the gas was in had changed, and so in relation, the pressure that was exerted on the pop can was decreased. So that's why, like it's still, yeah, I don't know. Does that make sense to you guys? I don't want to keep going in circles, but okay. So think about it like this: I have 100 helium molecules in my arms. I pull them closer together. Pressure is increasing, but the space that it can be held in decreases. Okay. So there was an old dead guy that thought of this too. He's dead now. Okay. He wasn't dead when he thought of this. His name was Robert Boyle. Okay. He was studying pressures and volumes of gases, and he said that if pressure increases, volume decreases, volume of the container, not this, yeah. So it's like the same amount of molecules. If they get put into a smaller container, the pressure will increase. It's different with our pop can because our pop cans stayed the same container, right? We didn't change the container until it crushed, obviously. Okay, anyways. So he came up with this correlation. He said that if pressure increases, volume will decrease. So our Irish scientist is Robert Boyle. He studied the relationship between the pressure and volume of gases at constant temperatures. So he wasn't changing temperature, okay? And like with our pop can, we were changing temperatures, so that will come a little bit later, okay? So we had another variable in there, was our temperature. But, so he just looked at pressure and volume and didn't change temperature, and this is what he observed. The pressure on the walls of container is caused by the collisions of the gas molecules with the walls. So as you reduce the volume of a contained gas, there is less room for the gas particles. So they collide more. More collisions equals higher pressure. So when we look at volume versus pressure, so on your graph on the y-axis, write volume in liters. And your x-axis is pressure in kPa. Now, as pressure increases, the volume decreases. So you have your diagonal line there. So this is really important for you to be able to graphically see something like this and know, okay, that's our pressure versus volume kind of comparison. So very, very important for you to know your graphs. Boyles Law states that the volume of a gas varies inversely with the pressure at constant temperature and mass. To inhale, we increase the volume of our chest cavity, which decreases the pressure, which makes the air move in. Good. Another application, say for breath hold diving, all air containing spaces in the body will shrink as pressure increases with depth. But the scuba gear helps to prevent that. So our formula is as such, where P1 times V1 is proportional or equal to P2 times V2. So it's like one pressure, so where P1 and P2 are pressures in kPa, V1 and V2 are volumes in liters. Oops, go back one. So it's like saying, here's the first scenario. If, say, a gas with the same temperature and the amount of gas was in this pressure and this volume, if we changed one thing, what would the other one be? So if we changed, like, say, the pressure, what would the resulting volume of that same gas be? So this is Boyles Law, okay? So go to your memorization sheet now, and we'll fill in this formula for Boyles Law. So this is the Boyles Law one. I think it's your second one down there. So just put this formula underneath the Boyles Law heading in your memorization sheet.